So in this section, we'd like to derive the orbit of bodies. We derived these equations. Then we'd like to express the orbit on the xy planes. So x-axis is agree with the direction of the C we choose. So as the direction of the C, we use the x-axis, agree with the x-axis. Then r vectors and the c vectors angle is expressed as theta. This theta. Then r dot c vectors becomes rc cosine theta. Okay, scalar product. So this becomes here. R dot c is here. And the r er vector becomes just r. So we have a second terms. So this is equal to L squares. Then R can be expressed L square over mu times G m sub 1 m sub 2 plus C cosine theta. If you divide the mu G m sub 1 m sub 2, you can move to the next lines. Then this terms we expressed A, capital A. This is E. Then we can move to the next. Right? And then we'd like to find out the eccentricity. Actually, E is expressed eccentricity. It becomes a capital C over G m sub 1 m sub 2. And the Laplace Lagrange vectors. This is Laplace Lagrange vectors. Then we'd like to find out the magnitude of the Laplace Lagrange vectors. Then take a squares. So this corresponds to the squares of the r dot cross L minus g m sub 1 m sub 2 er squares. This is equal to the squares. And they expand and take a square root. So first term is a square of the first terms. And second term square of the second terms. And the cross terms is the last terms. Okay. Then we'd like to consider each terms. First terms is r dot cross L. So this becomes r dot cross L and the sign. But always a velocity. And then this is L vectors. And the particle is moving on the planes perpendicular to the L. So velocity vector is perpendicular to the angular momentums. So this becomes r dot L magnitude L. And it becomes sine 90 degrees. Sine 90 degrees once. So r dot square plus L squares. And L squares can be expressed L dot mu. This is actually the L. And we use a triple scalar product. Then it becomes a mu r dot cross L. So this is r er. Then you can express the mu r. This term is expressed L square over mu r. Then you can substitute this here. And then r dot here, the first terms. Then E, eccentricity, can be expressed divided by gm1. It becomes a square root. 1 plus 2L squares over mu gm sub 1 m sub 2 square times 1 over 2 mu r dot squares comes from the distance. Minus gm sub 1 m sub 2 over r. Actually, this is exactly equal to the total energy. Energy of the E. The eccentricity is expressed as square root 1 plus 2L square capital E over mu times g m sub 1 m sub 2 squares. So for the elliptical orbit, eccentricity is equal to or larger than 0 but smaller than 1. So this means 0. This substitute this e is here, square root plus 2l square e over mu g m sub 1 m sub 2 squares than 1. So this means take a square root and then 1 minus, it becomes minus mu g m sub 1 m sub 2 squares over 2l squares e 0. Okay, so e have to be smaller than 0. When the e is minus mu g m sub 1 m sub 2 square over 2l square, in this situation e becomes eccentricity becomes 0. We consider it should be the circular orbit. Okay, then we'd like to move to the next topic of the semi-major axis. So we derive these equations. In the case of the elliptical orbit, we also derived this equation. If you look at these two equations, thetas correspond to the f, true anomaly of the f, and the e is correspond to this eccentricities. Then L square of the mu g m sub 1 m sub 2 should be correspond to the a times 1 minus e squares. Then we could consider 1 minus e squares. Then look at these equations. 1 minus e squares. From these equations, 1 minus e squares. It becomes minus 2 L square e over mu g m sub 1 m sub 2 squares. Then you can just substitute that equations here. Then minus 2L square e over mu g m sub 1 m sub 2 squares. Then we separate into the two terms. This times this one. Actually, this corresponds to the here. Exactly same with these terms. And this have to be equal to the a times 1 minus e squares. Okay, this have to be equal to a times 1 minus e square. Then 1 minus e square is cancelled out. So we discovered a semi-major axis of the orbit is equal to the minus g m sub 1 m sub 2 over 2e. So semi-major axis depends only on the energies. Okay, this is the end of these sessions.